Parity bits. Parity bit. So a parity bit is a type of check digit, and this is covered in an earlier video. The check digit is an extra bit added to a data message which is made up of binary data at its origin before the data is transmitted, and then it is scrutinized at the receiving end to determine whether an error has occurred in transmission. This will become apparent, the meaning of it, as we go through the video. We have even parity, where an extra bit is added to construct a string with an even number of ones, and this is covered in another video. And in this video we cover odd parity, which is an extra bit added to construct a string with an odd number of ones. Odd parity. So, example of odd parity, detecting correct transmission of data. So here we have Alice, and she wants to transmit this string 1010010. The string has 7 bits to it, and the string has 3 ones in it, so the string has an odd number of ones. In odd parity, a string has to be created with an odd number of ones. So what we do is that we add to fulfill the criteria of odd parity, a 0 is added to the end of the string before transmission, so this 0 here, and this extra bit is the parity bit. So we have an 8-bit string with an odd number of ones, 1, 2, 3, and this 8-bit string, which includes the extra parity bit, is now passed to Bob. So Bob has now received it. So upon receipt, at Bob's end, a calculation is done to determine the parity bit. And at Bob's end, the parity bit is calculated to be 0 with odd parity. So this 0 matches the 0 that Bob received. So we will say here that the string was transmitted correctly. So here we are using odd parity to detect correct transmission of data, and in this example there was correct transmission of data. Let's look at another example of correct transmission of data involving odd parity. We have Alice here. She wants to transmit this 7-bit string. This 7-bit string has 2 ones in it, so it's got an even number of ones. In odd parity, a string has to be created with an odd number of ones. To fulfill the criteria, if we add an extra 1 at the end here, which is the parity bit, we get an 8-bit string with an odd number of ones. So we see the string has 3 ones in it. And now we transmit this string to Bob. Now, upon receipt, Bob's end does a calculation to determine the parity bit, and Bob's end also calculates that the parity bit should be 1. So this 1 matches the 1 that was received, and again we will say that the string was correctly transmitted. So another example of odd parity detecting correct transmission of data. But also, odd parity can detect an error in transmission. So this can happen if 1 bit is sent incorrectly. Let us look at Alice again. Alice wants to send this 7-bit string. It has 2 ones in it. It has an even number of ones. But in odd parity, a string has to be created with an odd number of ones. So, and 1 is added to the end of the string, so we have an odd number of ones, 1, 2, 3. So we have an 8-bit string with 3 ones in it. It has an odd number of ones, and this is transmitted to Bob, but the string passed to Bob has an error in it. Let's look at the error. So this 0 here has now become a 1, so this string is incorrectly transmitted. Now Bob does a calculation to determine the parity bit, and at his end, the parity bit is supposed to be a 0. So this 0 does not match the 1. So we will say here the string was not correctly transmitted. So if one bit of the binary string is sent incorrectly, then the computer can pick up the error. So we're using parity bits here to detect an error in transition. But this error in transition can only be detected if one bit is incorrectly transmitted. Now, an incorrect message is sent here, but no error is detected with, it should say odd parity bit, if 2 bits are sent incorrectly. So here we have Alice here, and she wants to send this 7-bit string. And this string has 2 1s in it, so it has an even number of 1s. Now, in odd parity, a string has to be created with an odd number of 1s. So to fulfill this criteria, we add an extra 1 to the string, and we get an 8-bit string here, which has 3 1s in it, and so this has an odd number of 1s. And this 8-bit string, which includes the extra parity bit, is passed to Bob, but 2 bits are transmitted incorrectly here. So here, this 0 becomes a 1, and this 1 becomes a 0. So it is incorrectly transmitted. Now Bob's end does a calculation to determine the parity bit. And Bob's end, this 1 is calculated as the parity bit. So the value that Bob received and the value that Bob's end calculates matches. However, the string is actually incorrectly transmitted and the parity bit does not pick it up. So if 2 bits are incorrectly transmitted, then the parity bit will not pick it up. Questions and answer. If we are looking at odd parity, what should be the parity bit added to the end of these 7-bit binary codes to create the 8-bit binary codes? Pause the video and think what you will do. Okay, let's have a look. This code 1 has 4 1s in it. 1, 2, 3, 4. But in odd parity, you need an odd number of 1s. So, oops. Okay, let's just put this all on here. So, you have odd parity, you need an odd number of 1s. So you put an extra bit at the end for odd parity, and you have 5 1s here. 1, 2, 3, 4, 5. So the last bit, or the last digit, is the parity bit. So this is your answer here. Now for code 2, 10101010, this has 3 1s in it. And in odd parity, you need an odd number of 1s. So you put an extra 0 at the end here. So you have 3 1s in this string here. And remember, the last digit is the parity bit. And here in code 3, you have 4 1s. 1, 2, 3, 4. Remember, in odd parity, you need an odd number of 1s. So you put an extra 1 at the end, and you have 5 1s. 1, 2, 3, 4, 5. So the last digit is the parity bit. So here are your answers. Pause the video, make sure you understand, go over the video again. Thank you.